Yes, next give the heading to the, we are now entering in a new chapter. Here we are entering in a new topic, that is the mechanical properties of solids and fluids. And in that topic, we will discuss about the viscosity and all those things. So you will give the heading, mechanical properties of solids and fluids. This is the mechanical properties of solids and fluids. तो solids और fluids की mechanical properties के बारे में हम यहाँ पे discuss करेंगे. ये देखें, उसमें सबसे बड़ी property आती है which is called viscosity. Viscosity is a very not a small topic. It is a wide topic. That is of the topic of the, you can say, of the one lecture. Now viscosity is what? Viscosity is basically the property of the fluid. It is a property of fluid to oppose relative motion between layers of fluid. बेसिकली जैसे हमारे पास सॉलिड्स के बीच में फ्रिक्शन रोल करता है, फ्रिक्शन हमारे पास क्या रोल करता है? फ्रिक्शन के कारण हमारे पास हमने देखा ना कि इट अपोज द रिलेटिव मोशन बिटवीन द टू सर्फेसेस. सिमिलरली जो विस्कोसिटी होती है, इट अपोज द रिलेटिव मोशन बिटवीन द टू सर्फेसेस या फिर बिटवीन द टू लेयर्स ऑफ फ्लूइड्स. वो उसकी दो लेयर्स के बीच की उसको अपोज करती है, विस्कोसिटी जो होता है. इज इट क्लियर? नाउ द क्वेश्चन इज दैट कि विस्कोसिटी किस चीज पे डिपेंड करती है? Viscosity in fluids. Okay, according to Newton, when fluid is flowing through a horizontal pipe, then according to Newton, when fluid is flowing through horizontal pipe, then viscous force acting between layers of liquid is directly proportional to area of contact. Of layers, तो एरिया ऑफ कांटेक्ट पे निर्भर करती है. is directly proportional to velocity gradient. Means, let's suppose this is the horizontal pipe through which, let's suppose, the liquid is flowing. We know the bottom layer is still at rest. ये कुछ रेस्ट पे ही होगी. This layer, हम height y पे कोई layer लोगे, that is moving with some speed v. But if you will move more dy, this is moving with v plus dv. So the velocity gradient d v by dy viscous force Fs is equal to eta into is proportional to area of contact and change in velocity by length dv by dz. But it will be negative, and the proportionality constant is used. Viscous force, that is eta, is called coefficient of viscosity into A into dv. Negative sign is used because it is acting in opposite direction. So the negative sign is used because it is acting in opposite direction there. Is it clear? Now the similar thing here, eta is called coefficient of viscosity. And it depends on its value depends on nature of liquid. Unit of viscosity. So what is eta? Now if you will calculate the unit of it, it is mlt minus 2. Area is meter square. This is meter. And this is LT minus 1. It will become Newton second per meter square. Right? And if you will solve it as this 10 9 second per centimeter square. And this is also called the new thing that is called poise. So that is the viscosity here. How to define it and how to analyze it. Viscosity. This is the viscosity, that is, you can say it is the value is 10 poise. The value is 10 poise in it. Is it clear? So this is the value of it for the viscosity. Clear? Here विस्कोसिटी किनकी ज्यादा होगी? Liquid which are thick are having high viscosity. Like honey, grease, etc. So these things will have high viscosity of this. Clear? So it will have high viscosity here. Is it right? Yes, write down it. Please लिखेंगे इसको. Yes, the next is difference between viscous force and frictional force. What is the difference between viscous force and frictional force? देखो, अगर हम viscous force के बारे में बताएं, the first is it depends on the area of contact. अगर मैं इसके बारे में लिखूं फ्रिक्शनल फोर्स, this is independent of area of contact. Second, it is independent of normal reaction. depends on normal reaction. It depends on difference in velocity between layers. It is independent of velocity between layers, right? So these are the point here, the important things. Now the next is variation of viscosity. First, at temperature, with the increase in temperature, the viscosity the coefficient of viscosity between layers decreases as eta is inversely proportional to 1 upon root t. It is inversely proportional to 1 upon root t. Second, with area, with increase in area of contact with increase in area of contact between layers, the viscous force increases. So it increases with the increase in area. Clear? Yes. Next is Stokes law. According to Stokes, when a spherical body is moving through any viscous fluid then viscous force acting on body depends on radius of body, coefficient of viscosity, and velocity of body. मतलब if anything is flowing, then it depends on all these things. अगर कोई हमारे पास ये बॉडी है किसी फ्लूइड में मूव कर रही है विद सम v, तो इसके ऊपर एक विस्कस फोर्स रहेगी Fs on this body that depends on, well, it is depends on radius raised to power a something, eta raised to power b something, and v raised to the power c something. But we don't know the value of ABC. The value of ABC is calculated by dimensional analysis. So by dimensional analysis, this Fs unit is mLt minus 2 is equal to R is L. What is eta? Eta is Newton second per meter square. Newton second per meter square is mLt minus 2 per meter square. Means if you solve it, Newton second per meter square V LT minus 1 raised to power 6. This will become mLT minus 2 this is L minus 1, this is L की power A, this is L minus 1 raised to power B, L की power C. So L raised to the power A minus B plus C, M raised to the power B, T raised to the power minus 2 plus 1. That will become how much? Minus 1, minus B and minus C. So B is what? 1. Getting both sides. L is what? A minus B plus C is 1. And this is minus 2. So B plus C is 2. And B is 1, so C is 1. If B and C is 1, this will cancel out. A is also 1. So the force will come out to be is directly proportional to R raised to the power 1, eta raised to the power 1, V raised to the power 1. And the constant that is used, it is 6 pi. The force is 6 pi eta RV. So it is 6 pi eta R into V. That is a force acting on it. And you can say it is a Stokes law. It is a Stokes law. From there you can calculate the force acting on any spherical body when it is moving through any fluid. It is a force acting on any spherical body when it is moving through any fluid. That is the Stokes law. Is it right? या आई थिंक आपको अच्छे समझ आ गया होगा. हमारे पास स्टोक्स लॉ का हम इस्तेमाल करेंगे आगे. जैसे कोई भी स्फेरिकल बॉडी अगर किसी विस्कस फ्लूइड में से चल रही है तो हम इसका इस्तेमाल करेंगे कि उसके ऊपर कितनी फोर्स लगती है. विस्कस फोर्स जो हमने पहले न्यूटन्स के अकॉर्डिंग निकाली थी, दैट इज नॉट द फोर्स एक्टिंग ऑन एनी बॉडी, दैट इज द फोर्स विस्कस फोर्स बिटवीन द लेयर्स ऑफ द लिक्विड. but here I have calculated the force acting on any external body when it is immersed in a solid liquid, viscous liquid. Is it clear? So till now in the viscosity we have discussed what do you mean by viscosity. It is a property to oppose the relative motion between the second. किस चीज पे डिपेंड करती है? तो अकॉर्डिंग टू न्यूटन इट डिपेंड्स ऑन द एरिया ऑफ कॉन्टेक्ट बिटवीन द लेयर्स एंड द वेलोसिटी ग्रेडियंट. सो वी हैव कैलकुलेटेड माइनस ईटा ए डीवी बाई डी जेड. नेक्स्ट जो हमारे पास विस्कस फोर्स है उसके ऊपर और क्या किस चीज पे डिपेंड करती है? वेरिएशन कैसे होगा? तो वेरिएशन विद टेम्परेचर बढ़ाओगे तो विस्कोसिटी घटेगी. या फिर हमारे पास और किस पे डिपेंड करती है? थीटा, एरिया ऑफ कॉन्टेक्ट पे. नेक्स्ट वी हैव डिस्कस अबाउट द स्टोक्स लॉ, दैट इज वेरी इंपॉर्टेंट. यस, नेक्स्ट वी विल डिस्कस अबाउट द टर्मिनल वेलोसिटी. पहले आप इस चीज को सब लोग लिखेंगे. यस, राइट डाउन इट प्लीज.